Hi and welcome to my PlayHouse. And today I have been out purchasing stuff for my Patreon money. So Patreon has unwillingly purchased 3 solar charge controllers just because I needed one. But I most definitely wanted free shipping on my Amazon purchase, so I ended up buying 3. And yeah, I want to have a look at them, and I want to share with you and have a look at them, see if they're any good. And I already decided that I might have cheated myself here. So I was looking for a cheap MPPT charge controller, and just more or less I was just looking for something at a good price, because when you're gonna make a YouTube video, well, it's no fun just showing the most expensive one of them all, and because that's not very relatable. So I was looking for a good deal. So let's see if I got a good deal on these charge controllers. Okay, I changed the order on them a little bit, so that this is the cheapest, this is the middle, which is the largest, and then there is the most expensive over here. And let me just, to start with, reveal that none of them are that expensive. You can get some that is way cheaper than this, but I went for something like 10 euros plus. So this one over here, I paid 12.6 euros for this one. 12.6 euros. It's almost about the same in US dollars. This middle one, I paid 14.2 euros for that one. And this one over here, the most expensive one, 18.2 euros for that one. So there is like 6 euros from here to there, or the other way around, and 2 euros from here. Never mind, doesn't matter. And I thought, I was looking for a charge controller that I could take into the bunker and it would be able to run the bunker. And yeah, I was looking for a 12 24 volt charge controller, and I was hoping to get an MPPT, and this one is probably not it. I was cheated a little bit by this 50 volt input voltage, but with this, which I most definitely think is a PWM and not an MPPT charge controller, it actually is that there is one voltage if you're running 12 volt, and there's another voltage if you're running 24 volts on how much panel voltage you can put into this. This is a very tiny and cool little unit, and it has a very nice size display for the tiny little unit, but I have a screwdriver ready, so we'll go into that. So I do believe this is a PWM charge controller. Nothing wrong with that, it's just not as effective as an MPPT. So what is the difference on an MPPT and a PWM charge controller, I hear you asking. Do we have a piece of... it would have been nice if I had a thing here. If I can draw this. That's the charge controller. It has some power ports here. So I'm not gonna draw, but let's see, we have 2 solar panels here. And this charge controller is this one. So if we look in the manual of this one, we should be able to find what it takes in of power for 24 volts. I believe it should be over here. There. Max solar input 12 volt battery, 23 volts of solar coming in. If we are running a 24 volt battery, it's able to do about 46. The label here, though, claims that it's able to do 50 volts. I'm a bit doubtful about that. It also claims to be able to do 260 watts in 12 volt and 520 volt in 24 volts. That's probably... I don't think it's good to use this with 20 amps. That's a bit much. But well, I might. So a maximum of 23 volts. That's a much of a giveaway that it's not an MPPT, because an MPPT is able to take higher voltages. And we have 2 solar panels here. Let's imagine that. And a regular solar panel voltage for small solar panel is 18 volts. So we're gonna pretend that each of these are 18 volts and they are in parallel. So we have 18 volts coming in here to our solar charge controller, 18 volts coming in. So we have a battery connected to that as well. It's down here. It's whatever battery, doesn't matter for this, as long as it's a 12 volt or a 12, that's 12.6 volt if it's lithium iron phosphate. We have a plus and a minus there. So what a PWM charge controller will do is it's gonna take these 18 volts and it's gonna drag it down to what the battery can take. So it's we're connecting our battery here. We're just gonna blop blop, and it's not gonna convert that voltage in any way, shape, or form. It can only take whatever comes out of the solar panels. It will monitor the voltage down here and make sure that it's a good voltage, but it can't do anything with it. So we are very much limited to what kind of solar panels we're going to be able to use in here. We're probably not going to be able to go lower than the power that we need for the solar panels. So if we need 12 volt, I would expect something like 13, 14 volt as a minimum to work this. And then up to those 23 volts as a maximum. So a very tight configuration. And the other thing is also true if we want to run this in 24 volt mode, which just means that we connect a 24 volt battery. It can be one 24 volt battery or it can be 2 12 volt batteries in series. In that regard, we need something between 24 volts or 25, 26 volt and those 46 volts. So we could do that by putting these 2 panels in series. We would get something like 36 volts out of that, and 36 volt would be okay to power this PWM controller and charge a 24 volt battery. Awesome. Let's open up and see what's inside this door number 1. There we are. It only has a metal plate on the back here to dissipate a little bit of heat from these probably MOSFETs that are sitting here. So I see more screws, more work. There we are. It's out of the plastic. And yeah, if this was an MPPT charge controller, there would be some circuit to make it from a higher voltage to a lower voltage. It would need a coil like this. This coil is too small, it's just for the USB part, but it would need some coils to do that, and there is no coils here. These MOSFETs or whatever they are, they're just switching on and off stuff. Some of them are switching on and off between the solar panels, and some other ones are switching on and off the load depending on if the voltage is correct over here. So nothing wrong with this charge controller, it's just not an MPPT. It does what it's supposed to do, PWM. So for a tiny little project, I see nothing wrong with this. It's a perfectly good charge controller. It just doesn't have the MPPT. But if you follow my channel, you will have seen my solar project on my mountain in Portugal. This charge controller would be perfect for that. So let's pop it back in here. There is a temperature sensor there. That is impossible to get back in place. But yeah, never mind. I'll put the screws in later. Okay, later just became off camera. But this is I like this form factor. The connectors down here is a bit small and they're a bit far in, but more or less they look fine. So you can put your cables in there. Yeah, for 20 amps, I'm sure it's fine. You would be able to get probably a 4 or 6 millimeter cable in there without any trouble. So and that can handle 20 amps. I wouldn't use this for more than 10 though, just to be on the safe side. It has 2 USB ports. Awesome, I like that option. And then it has, well, you can use these connectors down here, but it also has solar in one of these round connectors here. And then it has the load out on one of these connectors. So it's kind of, this connector is the same as that one, and this connector is the same as that one. So it has a bit of dual purpose there. And here is the label again. This is the model K1688 solar charge controller. 1224 volts, 20 amps, blah blah blah. Here's the box. €12.60. So the middle one, it claims to be an MPPT. Ish. On the box here it says MWM and MPPT. I'm a bit confused how it can be both, but the manual does say that maximum input voltage of solar panels is 50 volts, and it doesn't say that we can't use 50 volts of solar panels when we're at 12 volts. So at the moment I have a charge controller like this running on my mountain in Portugal. This one is though, it's a 50 amps, where the one that I'm playing with down there is like 30 amps, and I can see the difference. This one is wider and it has metal out here. The one down there, I cut the plastic off the side, so I know for a fact that I wasn't cutting metal, I was cutting plastic. But how do they make it so that it can take 50 volts of solar panels on a 12 volt battery? Let's investigate. Take the screws out. So 14.2 euros isn't a lot of money, so this does look, that's a very big block of connectors that you can put some good wires in that thing. So what am I doing? It's stuck. Well, it looks like we have some beefy MOSFETs there. That's probably to turn on and off the load from the solar panels to the batteries. This thing up here only looks, that's just the display. Let's take that out as well. See? Yeah, this is the display. We have the same. We have 2 USB ports here. We have a little bit of a DC to DC converter thing for the USB ports. We have the display with a display driver underneath it. We have the cables that goes from one board to the other board. We have, yeah, this is just the voltage coming in. So this can be 12 volt-ish or 24 volt-ish, and this piece of the board will then convert that down to 5 volt. But these connections down here will be the same as the voltage coming in here. So that is not converted in any way, shape or form. But it does look like that is 2 output ports on this one. It does not look like it's DC output and DC output. So it's not like the other one where one is input and the other one is output. And we have 2 buttons and a temperature sensor. So yeah, not much of that. And then the bottom of this, there's nothing underneath it. Oh, there there's a little bit, but nothing important. So how do they make that 50 volt go into a 12 volt battery? I do not see how. I would be a little bit worried about that. So I must, for the amount of money that I'm paying for this, I'm not really disappointed. The build quality of this one, which is like €2 more, like this is a real piece of aluminium. It's thick, thick piece of aluminium. So yeah, this is a bit better. It does also claim to be able to do a bit more, but I don't think there's much MPPT inside of it. I'm a bit doubtful if that will work at all. But they do claim 50 volt solar panels, 12 volt, 24 volts. And the manual doesn't tell me anything about that. If I'm using 12 volt, well, I can't use 50 volts of solar panels there. So the one I have in Portugal is the 30 amp, and this one is the 50 amp, and there is also a 70 amp available. And the price difference from the tree was like ridiculously low. So we only have this one left. It claims to be MPPT solar charge controller. I'm doubtful, but let's. This one is also available in different models: 30 amp, 40 amp, 50 amp, 60 amp, 100 amp. Or we could take the English side of it. But this one is pretty much like the other one. If we see the manual here, do you see how this looks kind of similar? Like quite the copycat-ish. So I'm expecting to find about the same inside, except there is a few differences on the box itself. It has more USB ports. Awesome. We have 4 USB ports instead of 2, and these round connectors, which is also solar in and the load out, is located in the bottom instead of on the top. So yeah, I'll remove the screws and we'll have a look. So I have removed the screws from, yeah, this one is 60 amps. I doubt it. Like, yeah, maybe. Could be that it doesn't take much to just turn on and off the MOSFETs, so they don't really get hot. It's more like a relay, so that it doesn't get that warm. But yeah, if this one is 50 amps and this one is 60 amps, well, they are lacking quite a lot with the cooling. I also removed the next screws in here so we can take this out. And we can see the MOSFETs here. There's MOSFETs here, and they probably turn on and off the solar panels. And then there are some MOSFETs over here, and they're located near the load. So my best estimate is that they turn on and off the load. And a thing that I found here is that if we look at this, this is positive solar panel, and this is negative solar panel. And the positive, all of the positives are connected. Positive, positive, positive. So the positive solar panel is connected to the positive battery, which is connected to the positive load. So all the positives are just one short, and then it's the negatives. You can see negative solar panel, that pad doesn't touch any of the other ones, a negative battery and negative load, which correspond very well with these cutting on and off the load. So they're managing the negative side, turning that on and off instead of the positive side. And the positive side is how my brain works, but yeah, apparently they do it the other way around. Compared to the other one, these terminals, well, they're not bad, but they're not as beefy as the ones in the 50 amp. It's not an MPPT, even if it's claimed on the box here. It's just a PWM. I'm sure it does perfectly well. I wouldn't expect these 4 USB ports to be able to do much power. They say 5 volt 2 amps. It's probably all of them combined that are able to do that, but yeah, I wouldn't expect that you can connect to all 4 of them and get like 8 amps out of all of them, but yeah, it's fine. So, well, the build quality, I see some soldering here that is not great, but it does seem like it has, there is connection and stuff, but yeah, not that. I must admit, this one is probably, of the 3 that I purchased, this one was the most expensive, and I also think this one is the worst purchase I did. 60 amps? No way. Could be 10 amps on each of these, but yeah, I wouldn't run it, that's for sure. That would be pushing it. So let's pop that back in. So it very much looks like that these 2 are just about the same thing. This one has a little less USB ports, but other than that, I think they're about the same. This one is like 20 amps, and this one claims to be 60 amps. So where is MPPT different? Well, MPPT is different because the MPPT controller will DC to DC convert the voltage from. I've drawn multiple panels up here. So like I have 5 22 volt panels here, which gives total in series 110 volts DC, and that is too much for any normal low voltage battery, 12, 24 or 48 volt batteries. So the DC to DC conversion happens inside the MPPT controller, and the MPPT does so that, well, it can see how many voltage are available out here and how many volts do I need to push onto the battery. So it can create amperage out of voltage instead of this. It's not 100% efficient, but let's just say that we have this 110 volts and 1 amp. Let's say 1 amp coming out of that. So if you do a little math, 110 times 1 amp, that is 110 watts of power. 110 watts. When the MPPT charge controller works on that, it will take that 110 volts and make it 12 volt instead, and that will bring the amps up, which does not happen over here. It happens in some respects. It can happen a little bit over here. When you bring the 18 volts down, you might get a little bit more, but it's not nearly as much as it will happen over here. Let's just say 12 volt. Let's cheat a little bit and make this 120 volts just for the math. That also becomes 120 watts over here. So we just need to add 2 volts to each panel, so it's 24 volt panels instead. Blah blah blah. When we convert this, and if we just do it without taking the losses into consideration, well, if we convert that 120 watts into 12 volt, that means that we have to have 10 amps instead, like that. So now we are suddenly charging our battery with 12 volt 10 amps instead of where we would go over here. We would have 12 volt 1 amp, maybe a little bit more, but that is what the MPPT can do. It can reduce the voltages and give you more amps, and it can do it a little bit more smart than I have explained here. So it can pull the panels down to another voltage and figure out where do I get the most amount of power for this conversion. It might be that if we are at 120 volts, we get next to no amps. So maybe at 90 volts, we get a good amount of amps. So 90 times that amount of amps is more than 120. So a good charge controller can do some of that stuff. So let's go mess around in the basement. Okay, so the 3 charge controllers has moved into the basement where I'm gonna play a little bit with them. I have this battery. This is gonna be our battery. It's pretty low. I've had it in the bunker, so it has been discharging. I don't know what it's at. I can measure the voltage on it. It's not gonna take long. It's at 13.2 volts. So it's not high for a lithium iron phosphate, but it's high for a normal battery. One of the things that I want to see is if it's possible to power the charge controller from solar. Normally you need to connect the battery. That will make the charge controller turn on, but I would find it very beneficial if the charge controller could wake up when the solar power comes on. So I have a power supply over here. That one, that's gonna play our solar. So, but I'll just prepare a little bit and then I'll bring you in. Okay, I was gonna start with this one, but the plastic is very tight, so I had to go find a screwdriver that would actually go in and do the screws. So it's kind of, yeah, this will do the trick. I have made a little temporary thing where I have put some screws in. I will go over so I can connect the crocodile leads to it quickly. So we'll connect it to the battery, then it should turn on. Battery's there. There, and the charge controller turns on. So yeah, the load is on, and the charge controller says that the battery voltage is 13.4 volts, which seems just about right, as that was what we just saw. So it turns on fine with the battery. So I'm gonna try and give it some solar power instead. Okay, I am emulating being a solar panel. It's giving out about 22 volts. So down here I have hacked it. So now I'm having I had some Allen keys coming out of this. So this is the positive one and this is the negative one. So let's see what happens if it turns on. No, it does not. It does not do anything without the battery. So if we connect the battery, will it then turn on? Yes, it turns on and it starts charging the battery. So, but it does not turn on before the battery is connected, which is a shame. I can go through the menus. 14.1 volt battery, 14.2 something, 12.5. Yeah, the battery type is B02, which is probably wrong. 24 hours, load is off. So it doesn't have many menus, I must admit. I was hoping for a bit more. Next one, let's see, 22 volts coming in. Let's see if it turns on. Nope. Solar coming in does not turn it on, which is a bit of a shame. Okay, so now let's connect the battery to this one. I've connected some leads to it just to get it a bit further away. So as soon as I connect the battery, it's happy, and now we can connect our solar panel. This is plus and this is minus. There. So now it sees solar coming in. So it's doing stuff. Seems like no load. Oh, it changes the menu. It tells us what it's doing. 1.1 amp is coming in, which is approximately right. And it does something to the battery, brings the voltage up. PV solar. This one says it can do up to 50 volts, so let's see what happens though. I am seeing that it's drawing down the power of the power supply here. So you can see I had it set to 21 volt 1 amp. A 22 volt 1 amp, but it's bringing it down to 15 volts. So it does look like it's doing something MPPT-ish. So let's try and disconnect this and mess with the voltage a little bit. So let's disconnect there. Let's give it some more solar. So 33 volts. Let's see what happens there. Okay, so it's doing stuff. Oh, it still brings it down way. So it tries. Yeah, it's bringing in about an amp. I have no idea how much it's bringing to the battery though. Is it able to do more than PV? So it brings down the voltage, no load. And the PV, the battery, it's cold in the basement. Battery voltage, do we get amps to the batteries? Nope, it doesn't tell how many amps it brings to the battery. That is a shame. That's the MPPT that would go up, so it doesn't reveal that. Okay, and it brings down the voltage quite a bit. So yeah. Okay, last one. I have brought the voltage down to 21.5 volt. That's our solar panel. So let's see if our solar panel can power this. It's like the first one, so I don't think so. It's gonna be blinking probably. Yeah, it's blinking just like the first one. So they are definitely in family. So let's connect the battery. Minus and plus. There. That's the wrong order, by the way. You should connect the battery first and then the solar. So yeah, I did it wrong. So yeah, we can go through 11 degrees down here. Chilly. 1 amp coming in from the solar panel. It's 1.12, but never mind. Voltage, temperature, amp. Oh yeah, it starts all over again. No load. So okay, it works exactly the same as the first one. Okay, so what did we learn? None of them are real MPPT. So yeah, that is definitely a rip-off on this one because it says MPPT. This one says it on the box. I haven't seen, this one doesn't claim too much. I think it's the most honest one. I really like this form factor. I like the design of it. It's a little bit of a shame that the screws are so small, but I like the size of it, I must admit. I think it's a cool little charge controller. The one that I'm most disappointed with is this one. It was the most expensive one, and it's just like this one. Just not as tiny and small and cool. 60 amps. I would never put anything like 60 amps on this. So yeah, I'm a bit disappointed with this one. It wasn't too bad. It was 18.2 euros. So yeah, it's of course a bit of money, but you win some and you lose some, and that was a kind of a cheap mistake. I do kind of like this one as well. It's bigger. It seems better built, and it can go up to 50 volts, and apparently it can do a 12 volt battery on 50 volts, but I'm not sure that I'm gonna really need that. So yeah, this one is it has some really nice big terminals, and it's pretty well built inside. I do actually believe the 50 amps that might be okay. It might be able to do that. I wouldn't do it, but it probably can. Solar charge controllers are perfectly okay for a smaller project. if you don't need to put a lot of solar panels in series, like here, like having 120 volts or something like that, this is perfectly good. This can take these can take solar panels up to 23 volts in their 12 volt configuration. This one can take them up to 50 volts in the 12 volt configuration, and 50 volts in 24 volts and 50 volts in 24 volts. So if you're making like a smaller setup and running something of 24 volts, all of these are kind of equal of what they are doing. If you need 12 volt, this one is a little bit better. As soon as you go up to 48 volts, normally everything is MPPT. So why didn't I get an MPPT charge controller? Well, my idea was that I would try some of these PWM controllers and see if any of them was any good. And I do believe this one is perfectly good if I'm gonna use a small solar panel that does not exceed 50 volts. At the moment, I have the bunker connected to about 110 volts, so none of them works for that. The charge controller, which is an MPPT that is sitting in the bunker at the moment, is doing an okay job with that, because that was really cheap when I got it. Since then it has doubled in price, weirdly enough. There is the thing, if you have a small project where you need something like this, you can say, well, an MPPT will give you better performance. Yes, it will. These are like $15 each. An MPPT charge controller is closer to $100 in this size and range and stuff, 100 plus. So really, you can kind of purchase a 100-watt solar panel more instead of an MPPT. So let's say you have a setup with 100 watts of solar panels that you want to connect this MPPT controller to. So you can get this one for $15, or you can get one for $115, and the one for $115 will give you 20-30% more. Or you can get this one and you can just get two 100-watt solar panels instead, and that would actually increase your power more than getting an MPPT one. If your space for solar panels is limited, or you need to put them in series so you get over the voltages that the PWM controller can handle, well, then you will have to look into getting a MPPT solar charge controller. But you can get a long way with one of these, and you can just add some more panels for whatever money you save on not getting the MPPT charge controller. And in winter, this is a way better choice than the MPPT charge controller, because double the amount of panels is way better than an MPPT charge controller in the winter when there is not enough sun. So this is just about where I'm gonna leave you. All of these charge controllers were purchased by me with great help from my Patreon. So I will promote my Patreon a little bit. Every week I do a special Patreon video on Sunday that my patrons get, and you can get in on that on, I think it's $1. It's only two tiers. There's $1 and there's $3, and you get about the same. It's not about the money, it's about the community. And that is why on Sunday evening at 9 o'clock Central European time, I hang out with my patrons on Discord, and it's we talk about everything, and everything is in English. If anyone comes in there that doesn't speak Danish, we automatically change to speaking English, and we get to practice our English a lot in there. So yeah, come hang out on Patreon with me and the regular gang for as little as a dollar. So thank you very much for watching my videos. Do subscribe to my channel so that you can see me again, and have a really nice day.